We've now got Ansible as a major tool in our kit, so it's now time for the second major section of the course where we'll get professional with Jenkins. In this short chapter, I'll give a quick overview of continuous integration and continuous deployment. These industry practices are going to be applied on the course, so we'll have a talk about what they are. If you're already familiar with continuous integration, then you can safely move on to the next chapter, which is where we will get hands-on with Jenkins. Jenkins is, put simply, a tool that can manage builds. But why do we need a build manager? Well, before long on this system, we're going to have many different code repositories, all of which will be, presumably, continuously updated. On this course, we'll have a repository for the web app, a repository for Eureka, a repository for the global config server, and of course, we'll have a repository for the microservice. Well, I do want you to remember that just because we're only just starting out on this project, we're just sort of laying out the initial architecture. Once the course is finished and everything on the architecture is running smoothly, of course, we're then going to be developing more and more microservices, which we're aiming should be able to fit in really easily with the minimum amount of work. It would be a nightmare if for every new microservice that we commission, we have to manually check out the code, run the build, start a new server using Ansible maybe, and do all of the uploading and all the rest of it. We do not want manual management of that process. So Jenkins is going to give us a kind of a central hub where all of these builds are managed in one easy-to-use place. So with that in mind, as the, if you like, the architect of this project, we're going to mandate that every single push to any of our code repositories, and that means to the microservice repositories or the web app repository, is going to automatically cause a build to run. So that means we don't have to pay somebody to sit at a console all day, checking out code and manually running builds. It will be a completely automated process based on a developer pushing to a repository. As part of the build process, we're also going to run automated test suites. If any of those tests fail, then we're going to raise an alarm, and that alarm is going to mean that we would immediately focus on getting the problem fixed. If the tests succeed, then on this project, we're going to automatically deploy the new software into production, and I have a requirement that we're going to have the minimum of system downtime. Now, they're the requirements for this project, and I think these are kind of industry standard best practices. I realize that these requirements are not suitable for all projects. I can imagine that many projects would be horrified at the thought of the automatic deployment, and they might want to have some kind of manual quality control checking going on here. That's absolutely fine. But for this project, we are going for automatic deployment. And I know that the leading microservice projects, such as the often talked about Netflix, certainly do automatic deployments. I'm sure that many of you will already be familiar with the concept called continuous integration and the related concept of continuous deployment. Now, it's not really the prime objective of this course to learn about continuous integration and deployment, but it's kind of happened by accident here that what I just said on the previous caption is my requirements for this system is that we're going to continuously integrate and we're going to continuously deploy. Now, I'm sure many of you are familiar with this, but just in case if not, I'll give a quick overview of what continuous integration is all about. It's a development practice which has become very popular, and it's been talked about for the last 20 to 15 years, and now it's really becoming a kind of a mainstream development technique. So I'm sure many of you work on projects already that do continuous integration or are at least trying to do continuous integration. If you've not worked on a continuous integration project, then it's worth sort of talking about what it's about. And it's a reaction, I think, to what is commonly known, if I pick out the term here, commonly known as integration hell. And this is where, on a project of any reasonable size, and what I mean by that is, say, more than 2 or 3 people. So it doesn't have to be a gigantic project. Even projects of, say, 5 to 10 developers can experience integration hell. But it's certainly a problem for projects of 50, 100, 1,000 people or whatever. And traditionally, teams would work on their own modules or units, and then once those units or modules have been completed, we'd start a new phase of development called integration. And I have here a version of the waterfall model which you may well be familiar with. So after completing the requirements, you'd do the design, you'd then code the modules, test the modules, and then bring them all together in what's often called a big bang integration phase. So that's where the modules that have been developed here are brought together, connected together, and made to work with each other for the first time. The problem with the integration phase is typically that it was a very painful, long-running, and generally really difficult phase. And you'd have all kinds of problems that were not obvious at the previous stages suddenly coming to the fore here in the integration phase. And these could potentially be project-killing problems. And because in the traditional horrible waterfall model, this integration comes typically really late in the cycle, then this phase was always incredibly pressured. It was often running late, and generally it would be a dreadful part of the project. If I can reminisce for a moment, the first professional project I worked on was exactly like this, and their integration phase, which one of the senior developers there told me at the time was called internally, they called it the walking through treacle phase. And I'm not exaggerating when I say that this phase lasted multiple years. I can't remember exactly how many years, but it was a multiple of years just in that one phase. So think about it. That's years when the system as a whole wasn't running. So you couldn't actually see what the system could do. You could look at individual modules, but you couldn't see the system running. You couldn't do any system testing. And you didn't even necessarily know that the system was ever going to run. So during integration, there was always this risk in the air that the system might not even get completed. It was a horrible time, and the project was a success as it happens, but it did lead to a lot of burnout. A lot of good developers were lost in that phase, I think. So the idea of continuous integration then is really simple to state. Instead of doing a big bang phase of integration at the end of the project, we do integration all the time, from the start, from day one. We integrate continuously. The Wikipedia page here is a really good summary of the workflow involved, and there's some of the history there. It seems that Grady Booch may have been one of the first to use the phrase continuous integration back in 1994. And there's a list here of good best practices, and we're going to be following most of these on this course. So I'll just quickly run through them. Number one, we need to maintain code repositories, which I hope is self-evident. We need to automate the build. We couldn't do all of this manually. And of course, that's what we're doing in this part of the course. We're going to make the build self-testing. Well, as part of this course, we haven't really put any decent tests into our code. I'm going to leave that as a kind of an obvious step that would have been done. We are currently building a test-driven development course at Virtual Pair Programmers, which should be out very soon. And basically, all of the practices that are carried out in that course, you would be doing as part of development. A practice of continuous integration is that everybody, well, it says here, commits to the baseline every day, but to put that into Git terminology, that means everyone would push their changes to the central repository at least once a day. And the reasoning behind that is if I'm working on a set of changes, if I'm working on a feature or something, and that feature is going to take me 6 weeks, and I work on this for 6 weeks without ever doing a push, then of course what's going to happen in 6 weeks' time when I'm finished, if I then do a push, I'm then going to have to do a merge. And a merge basically means I have to do a big bang integration. Okay, well, it's 6 weeks of integration, but that could be really fraught with problems and really risky. Instead, if I commit every single day, even though the area that I'm working on isn't yet complete, if I'm pushing every single day and I'm ensuring that those changes are not breaking the build, then, well, I simply don't have a difficult and painful integration time in 6 weeks' time. I realize that's easier said than done if you're working on a feature which is going to have dramatic impact on the system, and it could be really difficult to push my changes when they're partially complete. Now, I can't really talk for much longer about this because we need to get cracking with the course, and this is sort of beyond the scope of the course. But if you're worried about that in any way, then I would recommend that you look up the concept of a feature toggle. It's a fancy word, really, but at the most basic level, this is just where you comment out temporarily unfinished pieces of work, or in some way the work that you've only partially completed doesn't affect everybody else's work. As usual, Martin Fowler has an excellent article on that. I do encourage you to check that out if it's new to you. Back to the continuous integration requirements, we want every push should result in a build. So again, we need something automatic here. We need to keep the builds fast, and it would be good if we could test in a clone of the production environment. Now, again, I'm not going into deep details on testing in this course, but I could certainly imagine that what we would want on this project is to use a tool such as Selenium, for example, which you may be familiar with. That enables me to test the actual front end itself, in other words, the full running system. And again, we have a course coming up on Selenium in the next few months, and I would definitely be looking to include Selenium as part of this process. Down at the bottom here, we have that everybody needs to be able to see the results of the latest build, which is fine. But finally, and this is a sort of extension to continuous integration, is where we go one step further and we say, when the build finishes, presuming it's successful, we're also going to automatically push the new software into deployment without any manual intervention. That's called continuous deployment. It's one of the requirements for this project. I realize that's a bridge too far for many projects, but we're certainly going to be doing it on this course. So that's it for this chapter. I realize that some of this has gone beyond the scope of this course, but I was aware that many of you would appreciate an overview of continuous integration and continuous deployment. So we will be putting all of this into practice in the forthcoming chapters of this course. So in the next chapter, we need a tool to do this. You can probably guess it's going to be Jenkins, and I'll see you for that.